Let us discuss about today the position of a circle with respect to x-axis and y-axis. So as we discussed earlier, this is a circle. Yes. Let the equation of circle be x square plus y square plus 2zx plus 2fi plus c is equal to 0. Call it as 1. Let this circle meets the x-axis in 2 points A of x1, 0, B of x2, 0. It means that this circle is passing through this point as well as this point. Therefore, 1 implies x1 square plus 2zx1 plus c is equal to 0. You call it as 2. Next, x2 square plus 2zx2 plus c is equal to 0. You call it as 3. So therefore, now when this circle passes through what? A of x1, 0, B of x2, 0, then indirectly we are putting the y value is equal to what? 0. So therefore, from 2 and 3, we can observe that x1, x2 are the roots of x square plus 2zx plus c is equal to 0. You call it as 4. Therefore, we can write which is a quadratic in x. It has a roots x1 and x2. Therefore, I can write as a product of the two factors. You call this as a phi. So it means that from 2 and 3 you can very well observe x1, x2 are the roots of the quadratic equation x square plus 2zx plus c is equal to 0. So therefore, when these two are the roots, I can write this quadratic equation as a product of two factors. Right, now, so when you got this one as equation of circle, then I can write the circle 1 as circle 1, or before circle 1, let us find out AB, the length of the chord on x-axis, or else we can say x-intercept made by the circle, or else circle made by the what? Intercept on the x-axis. So therefore, AB is equal to, apply distance formula between those two, it becomes x2 minus x1 whole square plus 0. So therefore, I can write this one as modulus of x2 minus x1. So here, what I told, roots I told, which implies sum of the roots is equal to minus 2z. Next, x quotient, minus of x quotient by x square quotient, and product of the roots is equal to constant by 1. So therefore, this is product of the roots, this is sum of the roots when x1, x2 are the roots. So therefore, this AB can be written as, that is A minus B. can be written as a plus b whole square minus 4ab. Means I can write this one as ab is equal to square root of x1 plus x2 whole square minus 4x1 x2. Once again, this is a minus b. A minus b can be written as a plus b whole square minus 4ab. Without this step also we can write, but you are very much comfortable, familiar with that in writing a plus b whole square, a minus b whole square. For that reason we could write this one is. So therefore, substituting the x1 plus x2, we have here 4g square y minus 2z whole square. Next, x1 x2 4c. So therefore, AB is equal to, taking 4 outside from the square root, yes, we could get AB is equal to what? 2 into square root of g square minus c. So therefore, this is called the length of the chord of the circle on x-axis, or else x-intercept made by the circle. X-intercept made by the circle is 2 into square root of g square minus c. This is defined only when, as we know already, the any quantity under square root must be positive or may be equal to 0. So therefore, this is defined only when g square is greater than or equal to c, or else g square minus c is greater than or equal to 0. Now, case 1. What is case 1? If g square is greater than c, g square is greater than c, then the circle x square plus y square plus 2zx plus 2fy plus c is equal to 0 cuts the x-axis in 2 points. They are a comma b, and length of the chord AB is equal to 2 into square root of g square minus c. This is when g square is what? Greater than c. Next, case 2. Let us discuss about case 2. What is case 2? Case 1 is g square is greater than c. What is case 2? G square is equal to c. That is when, if g square is equal to c, g square is equal to c, which implies g square minus c is equal to 0, which implies the length of the chord AB is equal to 0. Length of the chord AB is equal to 0, which implies the circle touches the x-axis at only one point. That is x1 comma 0. Here it becomes x1 is equal to x2 because they will become coincident, means the line touches at coincident point. So now when it touches at one point, this is the point x1 comma 0 at only one point, that is a of x1 comma 0. So therefore already we have written, that is x square plus 2zx plus c becomes x minus x1 whole square. Why? In place of x2 we have taken as x1, and meanwhile, so here x1 comma 1, x1 comma 0 becomes a point of contact of the circle with x-axis. I mean, x-axis is a tangent at only one point. And meanwhile, we have also written what? The sum of the roots is equal to minus g. Since x2 is equal to x1, therefore 2x1 is equal to minus 2z. Therefore, x1 is equal to how much? Minus g. X1 is equal to minus g. Now, when this is the point of contact, I can also write this one as what? X plus g whole square. X plus g whole square. So, therefore, I can also write 2zx plus c can also be written as x plus g whole square. So, therefore, hereafter, what's the equation of circle? The equation of circle touching x-axis is x square plus y square plus 2zx plus 2fy plus c is equal to 0. In this place, I can also write x minus x1 whole square plus y square plus 2fy. We can write this is the circle is touching the what? That is x-axis at only one point, where the point of contact is what? x1 comma 0. And we can also write, since x1 is equal to minus g, I can also write as what? X plus g whole square plus y square plus 2fy is equal to what? 0. This is also a circle which touches what? X-axis at minus g comma 0. But this discussion will be very vital while solving the what? Objective problems. So, therefore, the thing is, this is now it gives a very easy solution in doing the what? Very complex problems. Complex it will be more. This, if you know this concept, we can do that in any level, some sort of problems in an easy way. So, therefore, x plus g whole square plus y square plus 2fy is equal to what? 0. And also, this circle can also be written as according to this. Before that one is, we can also write x square plus y square plus 2zx plus 2fy plus c is equal to 0 can also be written in another way. In place of this, you can also write that is x minus x1 into x minus x2 plus y square plus 2fy that is equal to 0. This is a circle cutting the what? X-axis in how many points? 2 points. In the first case, g square minus c greater than 0. Okay, this comes under first case. Now this comes under second case. This and this comes under what? Second case. What is this? This gives an equation of a circle touching the x-axis at x1 comma 0 or else minus g comma 0. This gives a what? Equation of circle when g square minus c is greater than 0. Then the circle cuts the x-axis in 2 points. They are x1 comma 0, x2 comma 0. Therefore, the equation of a circle s is equal to 0 can also be written in the form of x minus x1 into x minus x2 plus y square plus 2fy is equal to what? 0. Yes. Now we come across it about what? When g square is equal to c, the circle touches the what? X-axis. When it touches x-axis at one point, say for example x1 comma 0, that x1 comma 0 according to this we could find out as minus g comma 0. So therefore s is equal to 0 can be written as x square plus 2gx plus c into x minus x1 whole square, or else x square plus 2gx plus c can be written as x plus g whole square. In place of this s is equal to 0, in place of whatever the terms we have, 3 terms, x square plus 2gx plus c, in place of this you can write x minus x1 whole square plus y square plus 2fy, or else x plus g whole square plus y square plus 2fy is equal to 0. So therefore this gives what? The equation of circle touching the x-axis at only one point when g square is equal to c. Right, case 3. What is case 3? If g square minus c less than 0, if g square is less than c, which implies the circle s is equal to 0 neither touches nor intersects the x-axis. So therefore here now neither the circle touches nor intersects the what x-axis. So therefore we come across the position of a circle S is equal to 0 with respect to x-axis under what? Three conditions. First, we could find out what? That is 2 into square root of g square minus c as the length of the chord on x-axis, or else x-intercept made by the circle on x-axis is what? 2 into square root of g square minus c. On that discussion, we have imposed some conditions. What is that? G square minus c greater than 0. Then the circle cuts the what? X-axis in 2 points. The length of the chord is 2 into square root of g square minus c. If it cuts at 2 points x1, y1, then it becomes x square plus 2gx plus c is equal to x minus x1 into x minus x2. So therefore, equation of circle S is equal to 0 can be written as, that is x minus x1 into x minus x2 plus y square plus 2fy is equal to 0. Next, when g square minus c is equal to 0, then the circle touches at 1 point. So therefore, means x2, 0 becomes x1, 0, means a is equal to b, b coincides with a, or a coincides with b, means circle touches what? X-axis at only 1 point in coincident points. So nevertheless, the point of contact becomes x1, 0. When x1, 0, as I told already, that is x square plus 2gx plus c is equal to 0. When x1, x2 are the roots, we wrote already x1, sum of the roots x1 plus x2 is equal to minus 2z, x1 into x2 is equal to what? C, correct or not? So therefore, with that, your point of contact becomes what? Minus g, 0. So therefore, x square plus 2gx plus c came written as x plus g whole square. So therefore, equation of circle x square plus y square plus 2gx plus 2fy plus c came written as x plus g whole square plus y square plus 2fy. When g square is equal to c, when g square is less than c, then the circle neither touches nor intersects. Okay. Now coming to similarly, when the circle S is equal to 0 cuts y-axis in the same fashion, what I told with respect to x-axis, cuts y-axis, that is in 2 points like this, x-axis, this is y-axis, this is A, this is what? B. Cuts y-axis in 2 points, yes, A of 0, y1, B of 0, y2. So therefore, then the length of the chord AB is equal to, that is 2 into square root of f square minus c, you'll get. So now here also, when f square minus c greater than 0, the circle cuts the y-axis in 2 points. When f square minus c is equal to 0, then the circle touches the y-axis in only 1 point. When f square minus c less than 0, the circle neither touches nor intersects what? Y-axis. This is the position of a circle with respect to x-axis and y-axis. Yes, now we have discussed about the position of a circle with respect to coordinate axis, x-axis and y-axis. Yes, now let us discuss when the circle touches x-axis having the center h, k. When the circle touches y-axis having the center h, k. When the circle touches what? Both the axes having radius what? A. Let us discuss about that. Before that, equation of circle touching first one, x-axis is x square plus y square plus 2gx, okay, 2gx plus 2fy plus g square I write. Why? When any circle S is equal to 0 touches x-axis, we came to know that already g square is equal to c. right? Or else I can also write g is equal to what? Plus r minus root c also you can write, right? So therefore, this is one way. Whenever, wherever, in place of c, if you have g square, it is quite obvious the circle touches what? X-axis. It is one of the best representation for touching the what? X-axis. Or else I can also write x square plus y square plus r minus root c into x plus 2fy plus, come on, that is plus r minus what? That is c is equal to 0 because g square is there. This also represents a what? Circle which is touching what? X-axis. Yes, now look here. This circle touches x-axis. This is one discussion, especially for the statements you see. Now, this is x-axis, you take x-axis. Now this is, you can also take another circle in the down, so therefore, in the above, so therefore here, f must be what? Negative. When f is negative, the circle touches the x-axis from the above, When the f is what? Come on, positive, then the circle touches the what? X-axis from the what? Downwards. Above, f less than 0, downwards, f greater than 0. So therefore here depends upon f less than 0, above, f greater than 0, below. So therefore next, the second one is, what is second one is? The equation of circle touching what? Y-axis. Equation of circle touching y-axis when f square is equal to c, or else f is equal to plus r minus root c, is x square plus y square plus 2gx plus r minus 2 root cy plus c is equal to 0, or I can also write x square plus y square plus 2gx, that is 2fy. I can write f square. This is also one way of representing the circle is touching what? Y-axis. So just by seeing the what? In place of c f square, you can understand the circle is touching what? Y-axis. Yes, now this circle touches what? Come on, y-axis from the right side, when g is what? Negative. From the left side, y-axis is what? G is what? Positive. Because in the second quadrant, x coordinate is negative. In the first quadrant, x coordinate is what? Positive. So therefore, now this is the circle touching what? Y-axis. Y-axis at only one point is given by x square plus y square plus 2gx plus r minus 2 root cy plus c, or else x square plus y square plus 2gx plus 2fy plus f square is equal to 0. Right. Now let us discuss about when the circle is touching both the axes. When the circle is touching both the axes. So therefore, when g square is equal to c, f square is equal to c, which implies g square is equal to f square is equal to c, which implies the circle s is equal to 0 is touching both the axes, that is x square plus y square plus r minus 2 root c into y plus r minus 2 root c into what? X plus c is equal to 0. This represents the equation of a circle touching both the axes. So therefore, if you look into the what? Come on, a geometrical approach, this is what? Y-axis. This is what? X-axis. This is x-axis. It may touch in what? It may touch in first quadrant. It may touch in what? Second quadrant. It may touch in what? Third quadrant. It may touch in what? Fourth quadrant. So therefore, this is the position of the what circle touching what both the axes. Now in first quadrant, this is in second quadrant, this is in third quadrant, this is in fourth quadrant. Okay, so therefore these circles, it may be represented with what? S common x square plus y square plus 2 root cy plus 2 root cx plus c. This may be what? X square plus y square plus 2 root c, okay, 2 root cx minus 2 root cy plus c. Here x square plus y square minus 2 root c, that is plus 2 root cy plus 2 root cx plus c. Here x square plus y square minus 2 root c into x plus 2 root c into y plus c is equal to what? 0. So therefore these are the equation of circles touching the what? Both the axes, maybe in the first quadrant, maybe in the second quadrant, maybe in the third, or in what? Fourth quadrant. Now we shall discuss about when the center is h comma k, when the circle is touching x axis and y axis. Equation of circle having center, yes, C of h comma k, touching the first one, x-axis, touching the x-axis. So therefore, if I look into this is the circle touching x-axis. If I take center h comma k, this is nothing but a radius. What is y coordinate of the center? K. The distance from x axis to this point is what? K. What we observe is whenever any circle having a center h comma k touching x axis is whose y coordinate of the center is the what? Radius. Why? To write an equation of any circle, you must have a center and a radius. Therefore, center is known. What about radius? The radius is obtained with the concept of what? The distance from the center or a point to the x-axis. Therefore, y coordinate of the center is the what? Radius. Therefore, we know the radius, we know the what? Center. The equation of circle is x minus h whole square plus y minus k whole square is equal to what? K square. Y. This in the form of, this is, okay, x minus h whole square plus y minus k whole square is equal to k square. So this is about the equation of circle touching x-axis. Second one. Now the circle, if it touches what? Y-axis. If I go to this one, this is the circle touching y-axis. This is x, this is y. This is center h comma k. This is nothing but what? H. Now what is the what? Distance. The perpendicular distance or distance from the what? Y-axis to the center is what? H. So therefore, the x coordinate measures the radius of a circle. You know the center, you know the what? Radius. Then the equation of circle touching y-axis is x minus h whole square y minus k whole square is equal to h square. Yes, now we have found out the equation of a circle having a center h comma k touching x-axis. Y coordinate of the center is the radius. Touching what? Y-axis. X coordinate of the center is the what? Radius. What about when it touches both the axes? Let us see. Now, equation of circle having radius A and touching the both the axes, both axes, touching both the axes, So therefore, let us see. So how this is, if I draw like this is the circle touching both the axes. This is the circle, both the axes, maybe in second quadrant, maybe in third quadrant, Yes, this is y-axis, this is y dash, this is x dash, this is x. Now this is origin O of 0, 0. Yes, those who are aspiring for the objective examination, you have a very good question on this, good questionnaire on this. Now once he asked in the JEE, so IIT-JEE, he asked one question. When the circles are having a radius A touching both the axes, and then the area of the quadrilateral formed by joining the centers of the four circles. Try to understand. The area of the quadrilateral, in another way, alter the area of the quadrilateral formed by the lines joining the centers of the four circles when they are touching both the axes. Let us see. As I told, this is radius. This is also radius. A, you take A, this is A, A. Why? You are in first quadrant. In the same way, this is B, this also A, this also A. Since you are in second quadrant, radius cannot be negative, but the coordinates of the center can be negative. Now you go towards, this is here. Now this is, okay, this is C. Now if I go to this one, radius A, you are in what? Third quadrant, center, whose coordinates are both are negative. Then if I go to what? D, this also A, therefore this becomes what? A, minus A. Now if I come to the what? If they ask us to find out the equation of what? Equation of a circle. Now the equation of a circle touching both the axes having the radius A is given to be x minus A whole square, y minus A whole square is equal to A square. Then coming to equation of this circle touching both the axes in the second quadrant can be written as x plus A whole square, y minus A whole square is equal to A square. Now I can write, now equation of a circle having the radius A touching both the axes in the third quadrant is given by x plus A whole square, y plus A whole square is equal to A square. Next, equation of a circle touching both the axes in the fourth quadrant, I can write this one as x minus A whole square, y plus A whole square is equal to A square. These are the respective equation of circles having the radius A touching in respective quadrants. That is Q1, Q2, Q3 and Q4. Yes, now we have discussed how to find out the equation of circles touching both the axes in first, second, third, fourth quadrant having radius A. Now I want to find out, this is the quadrilateral. This is the quadrilateral. Quadrilateral can be what? Rectangle, rhombus or square. Anything depends upon the lengths of the sides. So therefore, now ABCD is a quadrilateral. This radius is A, this also A, this also A, this also A. Total length is 2A. this length is also 2a, this length is also 2a, this length is also 2a. Therefore, we can say the quadrilateral ABCD is a square. What about the area of a square? X square, correct or not? So therefore, the area of quadrilateral, the area of quadrilateral ABCD is equal to 2a into 2a. Therefore, the answer is what? 4a square. This is the one of the important application when four circles are touching both the axes. Okay. So therefore, this is the equation of circle touching in first quadrant. This is the equation of circle touching in what? Second quadrant. This is the equation of circle touching in what? Third quadrant. This is the equation of circle touching in what? Fourth quadrant. So therefore, if you know this one, if you know the exact position of, now by knowing the what radius, by knowing the what common quadrants, you can write, you can remember, you can easily calculate the equation of a circle touching both the axes having the respective radius, and also the area of the quadrilateral found by joining the centers of what? Four circles. The area of the quadrilateral found by joining the centers of four circles is dash. The area of the quadrilateral is nothing but the area of a square. Length of each side is what? 2a. 2a into 2a is what? 4a square. So therefore, when the radius is a, then the area of a quadrilateral found by the line joining of the what? 4 points as the centers of the four circles is 4a square. If the radius is 2, therefore 4 into 4, it's about 16. When the radius is what? 3, now 4 into 9, it's about 36. This is about the discussion of the what? Touching circles for both the axes.